So now we are discussing an important aspect of this chapter, that is determination of Planck's constant. We can easily determine the Planck's constant with the help of a graph between the stopping potential on the y-axis and the frequency onto the x-axis. Now this graph is intercepting, the straight line is intercepting the frequencies at the particular value of frequency, which is the value f naught, which is the threshold frequency, and onto the y-axis it is intercepting at a particular value of the voltage, suppose v dash, which corresponds to a value of kinetic energy minus w naught over E, which is nothing but the work function of the metal. Now if we take a look at the Einstein's photoelectric equation, we have equation maximum kinetic energy equal to h nu minus w naught. Now if we suppose that v naught is the stopping potential, then we know that the maximum kinetic energy is equal to ev naught. So we can write this equation as ev naught is equal to h nu minus w naught, or v naught it will be equal to h nu by E minus w naught by E. We can also write it as v naught is equal to h by E into nu minus w naught over E. We keep this as equation number 1. Now if we compare this equation with equation of a straight line, y is equal to mx plus c. So equation 1 is actually the equation for this straight line which we are getting on this graph between the stopping potential and the frequency, where the slope of the line m is actually equal to h by E, and the intercept c is actually is equal to minus w naught by E. So over here, if we concentrate on the slope m is actually is equal to h by E. So from here we can write h is equal to m into E, which is equal to slope multiplied by the E. So when you want to determine the value of Planck's constant, we actually want to determine the slope of this graph. By multiplying that slope, we can, with the electron charge, we can find out the value of the Planck's constant. Or we can also find the value of the slope alternatively as you drop a perpendicular from the graph straight line onto the frequency axis. This is a right angle triangle with angle theta. We name the triangle A, B and C. So from the triangle ABC with right angle at the point B, tan theta will be equal to AB over BC. So which is nothing but the slope. So alternatively H can also be equal to E into tan theta. So again we are going to get the value of Planck's constant. Also the intercept on the y-axis is equal to minus w naught over E, which is, we can write w naught is equal to minus E into value of C. What is C? C is the intercept of the straight line onto the y-axis, which is giving us a negative value of the voltage, which we have indicated by V dash over here. So if we substitute that value over here, we can write minus E into minus of V dash, which is equal to E into V dash. So this value will give us the work function for the metal surface. So in this case, we can find out the Planck's constant as well as the value of the work function of the metal surface. Thank you.